Mm. So on the WhatsApp group, I sent some notes, right? Did you, everybody saw the notes? Had it downloaded and so? You'll have to respond to let me know that you're hearing me, you know. Y'all got these notes? Y'all saw them before? Anybody?
Yes, sir. It's in the group.
You saw it? Good, nice. If anybody joined late, maybe y'all could just resend it to them or, you know. Because every day you're seeing new people. So just want to make sure they get the notes because I still don't have a mobile access for the course, you know. I'm trying to get the course run off, nevertheless. Good. So what we're gonna do in this section of the course is basically look at some trigonometric identities. And we're gonna do two things with it. We're gonna use the identities to maybe solve some kind of equation, some specialized trigonometric equation, right? And then we're going to use the identities to prove other identities, right? Um, as I told you before, I always like to, you know, clear this up with students very early in any class. You too must do the same with your students in school. You know, lots of what you're going to do in this course. Anybody here is teaching A-level mathematics? Anybody in this group? Nobody? Okay, everybody's just maybe teaching at the CXC level or lower, right? Yeah. All right. So yeah, basically, you will not be teaching much of what you are going to learn in this course to anybody, right? And I don't I can't think of anybody in any profession where you are going to be involved in, right? That you're going to basically use the mathematics we're going to discuss. So why do the course? As I said, the underlying conception behind these courses, at least for me, UG might have other ideas and other members of the department might have other ideas. It is largely for the development of your cognitive processes. And therefore, um, well, I can explain how much I want. I can do examples how much I want. That doesn't help your cognitive processes very much. So to the extent that you engage with the material, right? And you know, you work the exercises and so you are going to get the benefits of it. And my assessments are just to see how much you have engaged with the material, right? So as much as you can, you have to do some reading. You have to take out your pen and paper. I may give you all these notes, but you have to actually try the identities, use them to prove other identities, solve equations using them. And if you don't do that, you are not going to benefit from the course. You are just here for a grade to get some paper, to get some job or keep some job or increase salary or all of that, right? Um, but if you don't engage with the material and really develop your ability to think logically, analytically, that's the name of the course, huh? It's an analytic geometry course. So you're not going to get those benefits if you don't engage with the material, right? Good. So let's start. How many of you have seen this identity before? This one here, tan theta equal to sine theta. It's identical to this means this is an identity sign. Identity. This is the equal sign, right? I guess you should know the difference between the two. Anybody can say? Anybody? What's the difference between an identity and an equation? Anybody can say? Don't be afraid. I guess you all have done a lot of courses together. You should know one another, and that's what I was saying. You know, put on your camera, unmute yourself, interact with one another. You can't come to a university and You just sit there passively and, 4 years gone by and they give you a paper. You haven't gone anywhere if you understand what a university is all about and studying is all about. Yeah, anybody can say what's the difference between an identity and an equation? But but I want to tell you something else you'll figure out about me is that I am not the answer key, right? You will be very disappointed if you think I'm the answer key, right? These days, the AI is the answer key. Google used to be. No, Google have developed so many these AIs that can answer you anything. Please find out. Know what's the difference between the two, right? And use it. Use it. Right? The difference between the two. Right? Please keep that in mind. I'm not going to everything you want. Sorry, I can't get out this. How do you to do it? If you have to spend your life figuring out the answer, well, so be it. That's how your brain is going to develop. If I tell you the answer, your brain don't develop, you don't accomplish anything. So what's going on? Right? So that's the first identity. And there are some others which we could refer to as the Pythagorean identities, right? I think people say Pythagorean, right? These are the three here. These here. Right? You probably, I don't know if you have done any course where you made use of these. Cos squared theta plus sin squared theta equal 1. Sometimes you might hear me use the word equal to when I should really say identical to, right? 1 plus tan squared theta is identical to sec squared theta. Cot squared theta plus 1 is identical to cosec squared theta. And I guess in your previous course, and you have to interact with me or else I will just move very fast if you don't interact with me, right? And you have heard of like sec. Anybody can say what? When I say sec, what's that? What's this really? Sec theta. What is it? Anybody can say from your previous course? Hmm? What is sec theta? What is that? You see this other one? I guess everybody here about cos and sine. So it's these I'm concerned whether you ever heard of them. Cosec theta, and then there's cot theta. Anybody know what they are? They say, okay, what are they the abbreviation of?
Secant and cosecant.
Yeah, very good. And the other
and
one,
cotangent.
great, great. Yeah, and feel free, if you don't interject, and you get off with me, man. You interact with me, interact with your colleagues, you know. That's how we're gonna have a class. Other than that, you don't even need to be here because I'm gonna record it and you'll stay home. And when it's posted, So that's how I try going through the material. But if you come, you want to interact with me, right? Yeah, very nice, very nice. What's your name? Who just answered there?
Nalini, sir.
Kamini?
Nalini.
Nalini. Oh, great, Nalini. Yeah, very nice that you have remembered these here. And I think what is sec? Sec theta is really what? 1 over cos theta, right? Tell me if I'm wrong. I can write wrong thing here too, Cosec.
That's
Do it willfully.
That's right.
Yes, yes. 1 over sine theta. Cot theta is 1 over tan theta, and so on, right? It's good to remember these, yeah. And for your own good, and what is the beauty of the internet now and all these AI agents, AI tools that they have online. You could actually ask them to give you proofs and to kind of explain what these ratios mean, and they'll send you to references and give you some notes on them that you can learn so much from, right? So use those things, right? Use those things, right, to help yourself to understand these things. Don't use things and when you go to a class or you're talking about something and you have no idea what they are. But that kind of information is out there now, easily accessible. Good. So with these three, I'll erase part this all of this because I think if I mistakenly save this thing, it's going to somebody write on the screen that it's not going to come off now. I saw a name there just now. Yeah, don't write on my screen, right? Unless I tell you to. Because when you write, see this here, I can't erase it because I didn't do it. Can that person erase this here? I think when I close this thing, it might ask me to not save or something. I hope so. Yeah. So try to remember these three, and the one on top, that's uh, just give me 1 second, 1 second. Yeah. So what can we do with these identities? One that we have with tan and then these three. What can we do with them? As I said, we can use them to solve equations that are of a particular type that they can help you to, do something to the equation that makes it simpler, right? To solve. As well as we will use them to solve or sorry, prove other identities that are there, right? Good. So let's take an example. Right? And tell me if my movement of the screen is dazzling your eyes and so, right? I can always, do something else that I didn't cut the example and put it on a slide and all that. I just said I'll scroll through and talk, right? Yeah. So look at this. You have an equation there, right? You have an equation. 2 cos squared theta minus sine theta equal 1. And you have to solve that for angles between 0 and 2 pi, right? So you're working radians there, right? Yes, in the last course, you were introduced to radian measure of angles and so, right? Yeah. So here we have cos, we have sine. And it might be difficult for us to know, say like, let's say, all right, you want to treat sine theta as x or cos theta as x, and, because it looks like a quadratic equation, basically, if you rearrange things, right? But the problem is that you have cos and sine. So what can we do to probably change everything to either sine or everything to cos, right? Good. The author here chose to replace cos squared theta with 1 minus sine squared theta. Where did they get that from? They get it from this identity, right? From here, you can see that cos squared theta is 1 minus sine squared theta, right? So we're replacing cos squared theta with 1 minus sine squared theta. Now, the thing about it is that people say, sometimes somebody might ask, well, why we didn't do it the other way around, where we replace sine theta with, something with cos. The trouble with that is that the identity doesn't lend itself to that because there's a cos square theta and then there's a sine square theta. The identity doesn't have sine theta inside, right? So, and one of the things you can do too, right, when you're doing a problem like this, you can say, all right, why not do it the other way? And what you will find is that trying the other way might very well indicate to you, and math has a way of doing that, that you know what, this thing is not going to lead you to the solution. And don't think that's a waste of time, right? Don't think that if you try the wrong approach and don't get the answer, you have wasted your time. You must never do that in any endeavor, not just mathematics. You know, I always refer to the guy who made the light bulb, Edison, right? You know, the man tried out the grass to see if the filament of the bulb can be made with grass. I don't know if it's a joke, it's a story or what, but I mean, the myth or the story has it that the man tried off the grass. Now, it's not a waste of time. At least he found out the grass can't work, right? There's where you, as a teacher in particular, you would know what can't work and what would work, right? And some of you might find several ways that work and several ways that don't work, rather than knowing just the one right way that works, right? Don't be afraid to be wrong, right? What you want to do is, if you are wrong, you want to learn from when you went wrong. You understand? That's a good thing about teachers, because I like Mr. Wynn's teaching you all any course. Mr. Wynn, anybody, you are doing a course with Mr. Wynn's. Peter Wins is his name.
No, sir.
No, sir.
No, oh my. What I like about him, he taught me, right? Of course, I don't know what it was. Many years ago. What I noticed when he's working with us is that he's not interested in who get it right. He's looking at all those who got it wrong, why they got it wrong, and if there was a certain pattern among those who got it wrong. And the reason why he was looking for that is that he's going to see, well, okay, what is the underlying thinking behind these students who are getting it wrong, or what you can do now to correct it. Who get it right, get it right. You can't care about them. They don't get it right. What you want to know is, how do you help those who get it wrong? So don't be afraid to do something wrong and oh gosh, let me waste my life doing this. No, shouldn't. There are benefits from going wrong. Right? By the way, I'm not an advocate of always learning from mistakes and experience. Right? There are some things in life you want to get it right the first time, right? Like courting the right boy and getting married to the right girl and that sort of thing. You don't want to trial and error that, right? So don't go tell people, I tell you, try out a marriage and it doesn't work, and then go to another one. That's not a waste of time, right? Please keep things in context. Right? There's some things you want to get it right the first time, right? That's all. Got married people here in the class.
Yes, sir.
Don't want to get that right the first time.
Yes, sir.
Great, yeah.
Yes, sir. Definitely, sir.
Yeah, you want to invest your whole youthful years, your time, energy in a relationship, and then get it wrong, and then you gotta go start and go back. Where do you get a mental energy and the other energies that you need to, do it over and over again? And the complications of those things. All right, good. Yeah. So now that we have actually changed everything to sign. So we removed the brackets, and so well, you realize what happened, right? They took everything to the other side, this side. So or they multiplied everything by -1 to get rid of any -1 sticking out in front here. And what you can actually see here is that this equation actually resembles, or it has the form of a quadratic, right? Everybody can see that. You can actually maybe take sine theta and let that be equal to a big X. So this equation becomes really like, okay, 2x squared plus x minus 1 equals 0. And this can be solved, right? That can be solved very easily. So I guess that is what is done on the other page. And that's what is done on the other page. Well, yeah, that's what it said here, right? They didn't actually change it to x and so. So you factorize. If you can't factorize, with that sign there, you can write it in the form of x and so, right? And then factorize. So you factorize and you solve. So you get two values for sine theta. You get half and you get -1, right? And with that now, well, you can find the values, right? So your primary value, right, this here, And this is your secondary value. Sorry, not primary. This is the principal value, right? I think sometimes we get confused with that. This is the principal value. And then this is the secondary value, right? Similarly with this one, sin theta equal -1. Well, within the range 0 to 2 pi, there's only one value, right? That's 3 pi over 2. So these are your solutions here. So this is another example, a little more unusual because the sine and cos, we are also familiar with it, right? So here is an example where you have sec and tan. So you have 3 sec squared theta minus 5 tan theta minus 4 equals 0. And you want the general solution. So some little differences there from the first one. If you have any questions about that first one, you can stop me, right? You can always say, sir, could you clarify this, clarify that, you know? Yeah.
Well, sorry, I have some questions, but I'll look at what you're doing.
No,
You can continue.
tell me the man one time so we can get some kind of discussion. Anything troubling you there? Tell me what troubling you.
Sir, when you using the identity, I understand the part where you
Okay.
where you replace the sign the cos square with you take it over the equation the identity, I guess, sign, and you have 1 minus sine squared theta, and then you leave the remainder of the equation. But what did you do to get how did you equate it to 0? Did you take the 1 over the identity sign? Sign?
I'll go here. Right? So you take this, you get 2 minus 2 sine squared theta minus sine theta. Yeah, minus 1 equals 0, right? Equals 0. And you multiply everything here by minus 1. Oh, this 2 minus that 1, you get it. Minus 2 sine squared theta minus sine theta, right? Plus 1 equals 0. Multiply everything by minus 1 and you will get it. Right? You don't like this minus.
Oh, we're multiplying everything by minus 1.
Yeah, that's one way, yeah.
Okay.
And you get that. Right? Yeah.
Mhm.
And that's another thing I want to tell you too, right? You when you that's why I give you the notes well in advance. I'm not criticizing you, I'm just telling everyone. So those who have the time, right? And you have to make the time for the course, right? To engage with the material. Take it and you look puzzling. How this guy do this thing, man? How this write together this thing? Take pen and paper. Don't be afraid. Right? Don't just read the thing and say, I'm gonna figure it out, I'm gonna figure it out. No, don't do that. Take the time. Take pencil and paper, right? And try. That's how brains develop, you know. That's how you develop your cognitive processes. You take the thing, you try the thing, you try the thing, try the thing. And you know, sometimes you start coursing in your mind, and so this chappy, this man, you know, how to explain things clearly. What wrong with this author? You know, like they make a mistake, you go back at it, you go over it, you go over it. A lot of people like to resort to going to YouTube and internet and so fast. Your brain doesn't develop when you do those things. Right? Your brain don't develop. And you see, as soon as as a matter of fact, I want to tell you this. My research has been in the area of beliefs in mathematics, right? What we call epistemology, right? Or your beliefs about the subject. And one of the things that I uncover is that anything you see as a student is always, as soon as they get a little difficulty, they run to the teacher. What, you know, they feel the teacher is the answer key. The problem with that, right, is that basically you're seeing the teacher, or you believe the teacher is the authority on the subject, right? You understand? You think that the teacher is all-knowing, right? Teachers like to carry themselves as they know everything and all of that. You know, they like to do that, especially smaller children. But as you get big, and I guess most of you are big enough to know, and you are teachers yourself, you know how very little you know, right? I tell people all the time, I know so little of anything, right? We all, the whole world knows so little of everything. You understand? So we're not all knowing, right? We're not all knowing. I mean, one of our students and you and all will behave like that, where the teacher is not necessarily the answer key, right? And you can figure out mathematics yourself. You are capable of doing that. But what it calls for is you got to know, take the time to engage with the material, get your paper, get your pencil, try this thing, all different angles. And I'll tell you what, sometimes you don't get something out today, right? And let me tell you, as you think about it, you sleep, some you dream about it, and tomorrow you get the thing, right? Or you know, middle of the conversation with your husband or your wife or something, and the thing comes to you, right? Or your husband trying to talk to you, or your wife talking to you, and you ain't listening one bit. So you working out the mathematics in your brain, and it comes to you, right? Your brain has a way of working on things even when you're not conscious of it. Yes, you know all of that from your psychology courses and so, right? You all know the story of the man discovered the structure of benzene. Anybody ever heard that story? Look at the man's name. Man studying, he's studying the structure of benzene, the molecular structure, that is, how the bonds are made, and so the hydrogen and the oxygen bonds and so, right? The carbon bonds and so. Can't crack it, because whenever you come up with how the bonds are, the structure of the molecule must explain its property. You have to be able to explain it. If the two don't work out hand in hand, well, you have to go to the drawing board again. Got to get him back into the lab. So the man is in front of his fireplace, and guess what? Man fall asleep, and he started to dream snakes, right? Snakes coiling up, and so on. Man jump up, man say, man, what's wrong with him? He's dreaming these snakes, and then he said, man, he had too much on his mind, So he rocking in the chair again in front of his fireplace, and the man fall asleep again. And he started to dream monkeys now. These monkeys, they're holding one another hand and the tail join up and so, right? So man jump up again, and I said, man, what's wrong with me tonight? Dragging all these dreams. And he started to recall his dream about how the monkeys are, intertwined and how they're connecting themselves with their hands and so. And he decided to go back and say, you know what, let me draw how these monkeys join themselves together in my dream. And guess what? The structure, the way the monkeys were joined together, hands to hands and tail to tail, actually is the structure of benzene that explains most of its properties. Right? And the man became, of course, world famous because of being able to, have a structure of benzene, come up with a structure of benzene that explains most of its properties. Right? Of course, he probably didn't tell that story much later, right? But anybody who dreamed the solution, people laugh at them, Probably you hear about Ramanujan and so from India, who said that a lot of his equations and so that he came up with, the deities revealed it to him. And that doesn't go down well in the scientific community, Yeah. But the point of the whole thing is that our brain has a way of subconsciously working on a problem, right? Even though you're not even aware of it, right? And you can actually, as you sleep, it's like you exercise in the gym. That's not what builds muscle. That breaks down muscle. But when you sleep, your body rejuvenates itself. The muscle grow back and get strong and all that. Same thing with the brain. You study something, and nothing beats when you disagree with what you're being taught. Right? Nothing is better than that. When you say, you know what? This is how everybody think about this thing, but I think this all y'all are wrong. Right? Disagree. And I say, well, you want to change something, right? You want to understand something, try to change it. Right? And the minute you start to disagree and say, you know what, I've proved so wrong, prove this thing wrong, prove that thing wrong. Well, there's where the brain development is going to happen. All right, I think I strayed off long enough there. I think when I finish, I got to edit this video so that my ramblings are not recorded. Yeah, so you got that now? So we got the equation and we're now factorizing, right? I didn't get my friend's name that raised the question.
Thank you, sir. I get it.
Yes, and if you can, factorize it with the sign inside, replace sine theta with an x maybe, like you see here. 2x squared plus x minus 1 equals 0. Factorize it up, like you do at CXC level, and then you put back, where you see x, you put sine theta, right?
Roger that.
Yes, and from there now you can solve using, well, notice they use both here. They use one time the quadrant diagram, and in the second time they use the graph of sine theta to pick out, well, where is sine theta minus 1 from 0 to 2 pi? Right. Learn to use these quadrant diagrams and the graphs and so. Then going to this one, same thing we'll be doing here. It's just that this one is a little different. It's using sec and tan, which we might not be so familiar with, right? So again, you want to replace, in this case, we're replacing sec squared theta with 1 plus tan squared theta. But there is an identity like that, right? So you put 1 plus tan squared theta where you see sec squared theta. Put it in there, you remove all the brackets, and so you get this. And again, you have a quadratic. Funny thing I think about this one is that you couldn't factorize it. You had to use what is it, quadratic formula, right? You can figure that out, that you're using a quadratic formula here, right? B is like this, B is minus 5, this is A, B, and that is C, right? The quadratic form. So tan theta is either this here or that, two values, right? From these, you will get a principal solution. So the calculator will give you this, right? Tan inverse of this is this. Tan inverse of this is this, right? And you all know this. Well, you should know from the last course. Did you do all of these things though? That the general solution is 180 and well, they're dealing with degrees here, right? You can have pi here too, pi plus. Then you can put this in radians. But in this case, this writer use degree. 180 and degree plus 61.57, 180 and degree minus 10.23, right? So yeah. That's the general solution there, right? Again, if you can't remember the general solution, just do a quick revision of your previous course, right? To refresh your memory and so on. Yeah, I think we did quite a number. Well, those I didn't say I should say quite a number. Oh, it's only 2. I want to go to an identity or 2 to prove it using those Pythagorean identity that we had before, along with the tan identity as well. Let's see. Let's look at this one. You want to prove 1 minus cos A times 1 plus sec A is identical to sine A tan A, right? How do you go about proving identity, right? Well, one of 2 things. Either you do this. You take the left-hand side and you break it down to see if it's going to be equal to the right-hand side. Or you take the right-hand side and you break it down to see or simplify it, whatever you want, change its form to see if it's going to be identical to the left-hand side. Or finally, and this is a little more complex, I think there is 1 or 2 you'll meet up with. You take the left-hand side, break it down to something, take the right-hand side, and break it down to see if it's also equal to that something. So if these 2 sides can be broken down to this common, third expression or well, then your left-hand side is equal to the right-hand side, right? So one of the three approaches you can use. Either you take the left-hand side and, do something to it, alter it, whatever, right? Not necessarily simplify, but um, you can do some alterations to it that it's identical to the right-hand side. Or you take the right-hand side and you do some alterations to it to see if you can get the left-hand side. Or you can use this more complex approach where take the left-hand side, break it down to something, and then take the right-hand side and see if it can be broken down to the same thing. Right? Those three approaches. So we're gonna see that with a couple of these examples here, right? I want to go these examples too again. And I'll encourage you to, right, to do this. Take your pencil, paper, and try these things, right? Try some of them, especially from the exercises, right? Again, sometimes you try it one way, it doesn't work. Don't give up. Don't feel you have to get it right the first time. This is not marriage, right? So keep that in mind. You can actually try different approaches. The thing about textbook writing is that the author probably tried 3-4 approaches and pick out the simplest one and put it in the book. And you say, man, look how easy the writer bring out the thing. Why I ain't getting the thing, right? And there's where sometimes some experience will come in. You will know some tricks that are out there in order to solve identity, right? I have a lot of students who, in the times past, I remember when I have this course in Bobby's here, students would come and say, man, sorry, I try all this thing and I ain't getting anything out, man. How you doing, man? Go on the board and do the thing. I said, look, I too don't know the answer. By the way, I've used this book since, 1988, I think. 1988 or 90, I wrote exam in 1989. I've been doing this stuff since 1988. You believe, oh my, I've done these things so many times. But lots of times I can't remember it. I watch the thing, I don't know what's the answer. But I said, look, you don't have to know the answer. If you know the answer, what are you doing the thing for? So what we do is we take the thing and say, all right, let's use the general approach, the logical approach to prove an identity. We'll take what we know, with what we're given here, and we're going to proceed logically. If we don't get the answer, because some logic sometimes not always works, right? Sometimes there's some tricks and so that you aren't aware of, right? That may come out as you walk through the thing sometimes. Sometimes people take a long time to actually come up with the right approach, right? Even though they might approach the thing logically and all of that, right? And you'll see some tricks that you'll want to know is, sir, how you expect me to know that if somebody didn't tell me? And yes, there are some things like that, right? Let's look at this one. This is very simple. So this writer decides to look. They're going to take the left-hand side. They're going to take the left-hand side. Kind of expand it. In other words, they're taking the left-hand side and working towards the right-hand side. You'll see if this thing can somehow break it down, simplify it, do other stuff with it, and see if you can get this right-hand side. That's what they do. So this author says, look, let me expand the thing like you would expand the product of two binomials, right? That's what they're doing here. They multiply here, and they get this whole long thing. So the author says, well, what about if I were to take this part here, and I write sec A as 1 over cos A? See what happens, right? And there's some cancellation going on, and and then this one cancels with that, you end up with that. So you get that. Still not this. Still not sin A tan A. What am I to do now? So they take this now. This here is 1 over cos A minus cos A over 1. And you do the thing, the LCM thing, cos A, cos A to cos A is 1. 1 times that is 1, 1 into this is cos A times that gives you cos square A, and this now turns out to be what? Sine square. So we end up with 1 minus cos square A over cos A. Still not what we want, right? And remember, this is not high school mathematics where, the answer must jump out to you in the second line. Good. So we replace the numerator now. Replace the numerator using one of those identities, right? With this. And then you take this now, break it up now. Sine A multiplied by sine A. And you take one of those sine A's and put it over the cos A. And this becomes tan A. So you now have the right hand side. You see? And that's how you do identities, right? The answer, I can't tell you step 1 do this, step 2 do this. No. Right? You have to decide your approach. Are you going to work from the left-hand side to the right-hand side? Are you going to work from the right-hand side to the left-hand side? Are you going to take the left-hand side and work towards a certain end result and then do the same with the right-hand side, You have to decide your approach and proceed, making use of, previous knowledge and all of that you have. What I like about the textbook is that you would not have an identity to prove that doesn't make use of a previous identity that you were given. Right? Keep that in mind. This textbook was well written. Right? These were English women, in fact, who wrote this textbook. And well written. I've been using it for many, many years. Right? So, I like this one. I like this one. Watch this one. So you have to prove this lengthy thing here equal to or identical to 1 over tan A cot A, right? So this is a good example where you took the left-hand side, and I'm not going to go through the steps. You're going to take the time to go through it in your own sweet time. So look here. They took this left-hand side, break it down to this here. But that's not our right-hand side. Right? Frustrating. So what you have to next do is take the right-hand side now. That's what in the next page. Take that side and also break it down to the common thing cos A sin A. See? And now that the right-hand side was simplified to cos A sin A, and now the left-hand side also simplifies to cos A sin A. Well, then we can conclude that if both of them simplifies to the same thing, then the left-hand side is equal to the right-hand side. I really like this. I really like that.
Sir,
Yes.
so based on this, it's safe to say that the identity is not always in the equation that is given, but sometimes in the solution. At least that's what I get from this one, because previously we could have attributed one side to what was given in the equation itself. But in this case, we had to simplify both sides to be able to say that they're identical because it's in the solution of each side.
I think you get the logic. This is solution, but it's a version, it's a simplification of both sides. Right? If you want to use that word loosely, it's a solution. It's not a solution really, but yeah. I think you got the logic of it. Right? You work on one side to simplify and you get something. You work on the other side, you simplify to get that same thing. So the logical thing then is that if this is equal to this and then the other side is equal to that also, well, then these two sides must be equal. Right? The left-hand side and right-hand side. If they both simplify, you said if the solution of the two sides are a certain thing, well, then left-hand side must equal to right-hand side. Right? You just use a different word there but the logic that you're applying is correct. Very good. Yeah. That's what this is saying.
Thank you, sir.
Great. Right? Yeah, and I'm happy that you're doing some kind of analysis, right? Rather than, just passively listen and say, I don't get it, man, I'll get it later. Nothing wrong with that, but it's good if you can actively, you actively engage with the example. Oh, and by the way, I didn't go through the details, right? You will bore yourself with the details as to, because I can go through all of this and get lost in all the details, right? But you can go and say, well, like, how come they make this equal that, right? And how do they take this and get this? And that's a mental exercise for you, right? Set aside some time, maybe 2, 3 times a week to do the course, and spend some time saying, how did Sir get this thing here? How did the author in the book get this thing? I ain't clear. Get your paper, get your pen, and you try to, follow the logic, right? You get something different, look at it back again. And this book doesn't have so many errors that, I'll tell you there's an error. Good. And then there are some other applications like you see here. You can use those identities earlier to, to eliminate theta. Like you have, maybe this is like what we call a parametric form or a parametric equation. X equal to cos theta, theta being a parameter, y equals 3 sin theta. You want to get rid of the theta, man. You want only x and y, right? And, well, what it is squared cos theta, right? And then it's square sin theta. You transform the equation to get cos theta and sin theta. You square both sides, add them up and put them equal to 1. And in that way, you actually eliminate the cos square theta and the sin square theta, and you get what? X squared over 4, plus y squared over 9 equal 1, and you do some more algebra and you end up with this. And anybody can remember what is this equation of? 9x squared plus 4y squared.
Equation, sir.
What's that? What is that?
Equation of a circle.
A circle.
No, circle, I don't think you can get to. If you have 9 and 4 in front of x squared and y squared, it's not a circle. And I'm not going to tell you either, right? So you should figure out what that is, right? But a good start. Somebody suggests a circle, and well, it's an opportunity for you to. Well, you can get back to your old course, or you could just type it in on the internet. Right? Anybody lazy enough to just type the thing in the internet and say, what is this the equation of? And the AI tells you what it is. Right? You hardly need me to teach this course, to be honest. You think you know. What you need from me is just the test. Cesar, 3 weeks from now, bring a test. I don't like it. Yeah. Okay, look, another type of equation that you can solve. What do they want? Oh, it's not an equation to solve. They want to, you give a sign A, and you give the information that A is obtuse, right? You all must know what is an obtuse angle, right? And you want to find cos A and cot A without using tables or calculus. So, all right. You use the identity cos square A plus sin square A is identical to 1. Sin square A is going to be 1/9. From this, then you do your little subtraction, and so you take it over, subtract, find the square root, and you get cos A being 2√2/3. Right? So they're giving you a little bit of reasoning here, right? You can read this. A is obtuse, so you're not going to use the positive value, right? Because in the second quadrant where it's obtuse, A is obtuse. Cos A got to be a negative value, right? So you're using the negative, right? Right? So you solve that first part where they say cos A, you want cos A. And next you want cot A. Now cot, we earlier learned that just clarify this because this might puzzle you. You learned that tan theta is equals to sine theta over cos theta. Remember that cot theta is 1 over tan theta, right? Therefore, cot theta is also equal to cos theta over sine theta. The other way around, right? Take this and flip it over. You get it. So we are already in the problem. We know what cos A is. We just find it there. We knew you were given what sine A is. So you just do your division, all right? You divide that by that and you get the division. Right? So, I mean, the applications of these identities, I would say they're endless, but you can have a lot of applications. You never know when they can be used. You never know when. And somebody can come up with something new, a new application anytime in the future, right? So the idea in this lesson is not to exhaust all the possible equations and all the possible identities that you can use the Pythagorean identity to prove. No, I can't exhaust all, right? It's just to introduce you to them and see how they can be used, right? And but here's a nice exercise, right? I think I've given you the answer for all these questions, right? I think you have the answers to all these questions at the somewhere at the bottom there, at the very end of this these notes. So you can try, you know, I don't expect you to try all. Or maybe you can say, man, let me try question 1, let me try question 5, you know, different types. Let me try, okay, this one give you a range, but this one give you the one general solution. Let me try 1, let me try 2. You know, you can't prove all these identities, right? There are a lot, right? You got 19 identities. Maybe what if I do all the odd, right? Somebody else prove, say, man, let me do all the even. And there's nothing wrong with you collaborating with one another and use the group and say, man, you know what? I prove question 11. Somebody look at it and say, you know, what you have to say about it. Another person say, all right, you do question 11, I'll do question 13. You know, another person say, I'll do question 14. Right? You can use that group for that kind of thing. Right? No problem. Collaborate. Right? Try stuff on your own. Good. So, all right, these are all, yeah, more exercises you can try. Do you want a 5-minute break? Before we go on to compound angle identities? Want a 5-10 minutes?
Okay, sir. Thank you.
All right, we'll take 10 minutes, right? We come back at 5 after 5. On the resume recording, yes. So looking at the compound angle identities, I just want to highlight how they move from one to the other. Right? Let me go back to the exercise. So when you have sine A plus B, right? It's identical to sine A cos B plus cos A sine. All you're doing in this one, notice you are replacing B with minus B. Right? You're replacing B with minus B, and you will figure out from maybe your earlier course that, well, okay, down here is supposed to have cos of minus B, right? And down here is supposed to have, I'm just showing you how they move from one to the other, sine of minus B, right? So from your knowledge of the trigonometric identities, let me just, the trigonometric function, right? You know the cos curve is symmetrical about the vertical axis, right? So in other words, let's say B is here, right? Minus B, sorry. Minus B and B is here, right? So the cos of minus B is identical to the cos of B, what's right here, the same value. So cos of minus B is equals to cos B. And that's why you don't have cos of minus B here, because cos B is the same as cos of minus B, right? That's just a property of the cosine function. The sine of B. Why do we have sine of B here, not sine of minus B? But if you look at the sine graph, I'm going over here now, right? The graph looks something like that, and it comes down like this here, right? Right? Good. So let's say minus B is here. Right? And if you draw down, you come across and you read off this value. So let's say this is S, right? So if you were to take, you notice this part of the graph, this line here, this part here, it's very much like the line y equal x, right? So positive B here, if you were to draw up this value here, is simply going to be, if this was, let's say, minus S here, this is going to be positive S. Right? Let me call this minus S. So this is positive S. In other words, sine of minus B is the same as minus sine of B. Right? That's a special property of the sine curve. And that's how they did that. And all the rest, they did some tweaking and they came up with them. Right? If you want to spend some time studying them and getting to know how one is derived from the other, it's a worthy mental exercise. Right? It's a worthy mental exercise. If I tell you all the little bits about it, well, you're not going to learn it. Right? You can take your time. For example, let me just show you what I'm talking. Yes. I give you go up. Notice to prove the first one. Notice this one. From the first one, you see they have a diagram here, and they're using that to prove that sine A plus B is equals to this. This is more of a, what I call a trigonometric or a geometric proof, right? A geometric proof, right? As a matter of fact, there are other proofs out there. Oh, by the way, I should mention this interesting story. Y'all heard about the two high school girls in America. And I should say this, they were two colored girls or black girls. Two senior high school black girls were able to come up, I think they said independently, of a new proof of the Pythagorean theorem. You all heard that story? They were on 60 Minutes and so many shows and so. You all heard that story? Anybody?
No, sir.
Yeah, it was very inspiring, right? Here are two high school students. After 2,000 years, came up with a new proof. Oh, by the way, the Pythagorean theorem have hundreds, I shouldn't say 100 here. There are lots of proofs out there of it. But these two girls, they came up with a new proof, right? One that was largely based on trigonometry. When I watched the whole thing out, there was some calculus inside and algebra and so. They were claiming that it's purely trigonometry, but I don't agree. Everybody's excited; they kind of ignore that part. But what was remarkable is that these are two high school students. Better yet, they were colored students, or what we call, they were black girls, right? Usually when you think of a mathematician, what color comes to your mind? You know, you only think white people can do mathematics, right? Or Europeans and so. So here, these are two high school girls, black girls, who were able to come up with a proof. I'll probably find that video and send it to you. It's rather inspiration, right? Very, very nice. Those girls are world famous now because of coming up with a proof, right? So don't think that this is all there is. If this one is puzzling you, go see another one on the internet, right? And from there now, this exercise here takes you through how they found all the others, this exercise here, right? So engage your mind, take your time and say, look, how is it they got this? Look here, right? See, people replace B by minus B, right? And they tell you, well, try to figure out how is it they get that this equals this here. Well, I explain why you have cos B here and not cos of minus B, right? As well as why we have minus here and the sine B instead of sine of minus B. I just explained that. But you now can go down and there's a wealth of information here, or a lot you can learn from going through these exercises. Notice what they're telling you. In the identity derived in 1, that's, I think, this one here. No, sorry. This identity here, sine A minus B. Replace A by pi over 2 minus A to show that cos A plus B equals to B. Right? And I think why they're telling you that is that, where is it? Replace A by this. Anybody knows why you're doing that? Why you can replace A by this? Anyway, it's something for you to think about, right? Think about why they want to replace A by that, right? Why is that equal? Why is A equal to pi over 2 minus A? Why? Right? They're really referring to like the sine of an angle, right? Is equal to the cosine of its complement and all of that. It's all entangled there. When you go through this, it's a word exercise. Take a couple. Sometimes you don't do all, but you go to try one. How did they come up with this identity? Cos A plus B is identical to cos A cos B minus sine A sine B. How they come up with that? Right? Don't rush to YouTube. Don't rush to the AI. You try to figure it out. That's where the brain development comes. Right? The minute you see you like to rush to YouTube, right? You know you can't rush to me because I told you already I'm not the answer key. So you say, no, I go into YouTube, you know, or I go into an AI. What you have to understand is that these things tend to have a domino effect on us, right? We stop thinking and we just run into, you know, like you're running to the source or the authority, right? A lot of times I tell you AIs can be wrong, right? YouTube sometimes lots of stuff that they are presenting here might students coming up with all kinds of terms and so they use it and say, oh yeah, we don't hear them terms, you know, YouTube, sir. Right? Be careful. The difference with a textbook, right? The difference with a textbook is that this book is written. This book has been around since the early 90s. Right? This book has been time tested. The whole world read this book and know that what is inside is correct. You choose a man when you check it, you upload a video last month, the other month. God knows who he is. Is he a high school student? Is it an AI talking in a YouTube video? You know, is he misleading you? You don't know. Right? So try to develop your own brain. That's the whole purpose of you doing mathematics. Right? So go through this exercise. You might not be able to do everything, but at least try some activity that is suggested here. And see if you can come up with any one of these here. Right? So this is the whole bunch of them. You will have an open book test, so you probably have your notes written out. You have all your identities written out on a piece of paper, right? In your test, you wouldn't be allowed to scroll through another file because the computer is going to register when you switch tabs and so you might be in trouble if you do that. So you have to write out this on some answer, not answer, on a what do you call it, formula sheet, right? And use it forever. So I'm not expecting that you memorize it. When I was a student, you had to memorize all these things, right? And people feel now if I tell you that say, this man is a hard man, this man wants all of you fail. No, this man wants you to use your brain for once, right? I don't want to be hard. I want you to develop your brain. So when you come out of this course, you come out of this degree, your brain is operating at this peak level, right? You want to make the world, break the world and make it back. You understand? Good. So let's use it. Well, we're seeing some uses here. This is when a calculator. Well, I don't know if you all know about tables, 3-figure and 4-figure tables. When I wrote CXC, calculator was a luxury. You had to be a really rich person to get a calculator. We call a scientific calculator. I remember as a boy, when I went to buy my first scientific calculator, my brother took me to Georgetown, a place named Rock Street. And we walk in store to store, can't find a scientific calculator in whole of Rock Street. I think we eventually found the store, and man, I think I remember paying, it's $480 for a calculator, right? Scientific calculator. Very expensive at the time. So this kind of problem is the kind you solve when there was no calculator. You only had 4-figure and 3-figure tables you had to solve. And people did those calculations with hand, Yeah. Make up those books. You write CXC, they used to share them out. So you go and sit down in your room and you don't have a calculator, so you share out 3-figure and 4-figure tables. I remember where I stole a 4-figure table from the exam room because I was so intrigued by the thing. I said, I'll never have this in my whole life. I just stole the thing. When they're collecting back materials, I didn't give them back. I had it for many years. It was just a bad reminder of me later on. I said, man, no, this was when I was a thief. Yeah. Okay, good. Sine 75 degrees. So you want to see that as sine of 45 degrees plus 30. And well, you should know from elementary trigonometry what the sine and cosine of 45 is, right? In terms of sorts. You see them here, right? Root 2 over 2, root 3 over 2. You should know those, right? I know those from elementary trigonometry. Here you got thing, man, you take a triangle, this side is 1, this side is 1, then this side is gonna be root 2, right? So the sine of 45 degrees is going to be, what is it? 1 over root 2, which is really root 2 over 2. I know the thing. The cosine of root, this is 45, right? 45 here, 45, 45. Then there's that thing about the, you divide here. So this is 30 degrees, 30 degrees, 60 degrees, 60 degrees. Down here is, what was it? I think they had 2, I think it's 2 down here. So this is 1, that's 1. I'm trying to remember if this is 2 here, and then this side is going to be root 3, something like that. Y'all remember that from high school? So there are the standard values for 45 degrees, 30 degrees that you will know, right? Sine, cosine, even tangent, right? So you put them in there, you see them here, and then you simplify. Anybody remember all of this from high school? No answer. Yeah, so look at these examples, see how, look at this one, tan of minus 15. Let me see what they have for that one, tan of minus, okay, interesting. It's equivalent to tan of 45 minus 60. As I said, the tan of 45 and 60 are values that you should know from elementary trigonometry. You don't have to have a calculator for that, right? You see it here. So that's one use. Let's see another one. Let me go to another one. Okay. They're proving an identity here. You want to prove, what is that? Sine of A minus B over cos A cos B plus sine of B minus C over cos B cos C plus all of this whole long thing equals 0. It's identical to 0. Right? So you use a compound angle formula to expand the numerator. This is the expansion here. here, right? And what do you do? They take each term and split them up into two. You see that? You put sin A cos B over the denominator. You do the same here over the denominator. You split them up, each fraction into two parts. And then maybe a whole lot of canceling is going to happen. And then they all simplify to a set of tans that all cancel down to zero. Right? You will take your time and go through them bit by bit. Right? Nice mental exercise for you. All right, let's look at an equation. You have this equation, you have to solve it, you have some sign inside, you have cos inside. But it's not like the ones where you could have used like sin squared theta plus cos squared theta equal 1. It's not the type. You see something like a compound angle here, theta plus 30 degrees, right? So what do? Well, we try to expand that. That's the approach this author is using. To expand out this side, okay? So you know cos 30, you know sin 30, because those are values there, root 3 over 2, half, right? You put them in, simplify further. What is it simplifying further now? Take this half cos that over, minus it from the 2 cos theta, so you get 3 over 2 cos theta equal to root 3 over 2 sin theta. Bring down the cos theta, divide, take this over and divide. Some algebra going on here. And you end up with sin theta over cos theta is 3 over root 3. Right? Which simplifies to root 3, right? So tan theta, so this equation we had at the beginning here, after some, simplification comes down to tan theta equal root 3. And these are your principal solutions, pi over 3. And your general solution is n pi plus pi over 3. Well, you're dealing with radians, so that's why we're using this form, right? So that's a simple equation here that you can solve using the compound angle identity, right? You're following? You're following this example? Was this difficult? No thought? You go back to it. It's not anything difficult. You simply use your expansion. Cos 30 is root 3 over 2. Sin 30 is a half. You take this half cos theta, bring it over here, subtract it from the 2 cos theta, you get 3 over 2, And you take over this, divide, you bring over the cos, you divide, Not very difficult. And then you have a nice exercise here to try, right? That involves, you don't have tables or a calculator, you place in that situation, what do you do? Have some identities to prove. Might not be able to prove all of them, but try one or two now. Try one or two, right? Then these are some equations that involve, notice, compound angles. Try your hand at them, right? Try your hand at them. And oh good. So I think I'll stop there. I want to kill you one day. Yeah, I'll stop. Stop with this.